Hello everyone, my name is Ala Sayed. I'm a fifth year medical student at King Saud bin Abdulaziz University for Health Sciences, and today we're going to talk about thyroid physiology. We will talk briefly about the anatomy and the histology of the gland. We will talk about the synthesis and secretion of the hormones, a brief comparison between T3 and T4, and also the functions of the thyroid hormones and what control their secretion. The gland is located above the trachea, and it's made up of a left lobe and a right lobe joined by the isthmus. Using the microscope, the gland will actually be formed of follicles. As you can see here, this is one follicle, this is another, and this is another follicle, and this is another follicle. And this is the functional unit of the thyroid gland. Now, each follicle is composed of small cells. As you can see here, this is a cell, and this is a cell, and this is a cell. Each cell is actually called a follicular cell. And the follicular cells are the cells producing T3 and T4, or in other words, thyroid hormones. And inside each follicle, we can see a more pale area called the colloid. Now, the colloid is actually the area where thyroid hormones are actually stored. Now, the colloid is made up of a glycoprotein called thyroglobulin. Thyroglobulin is actually the location in which the hormones are actually synthesized and stored. Between the follicles of the thyroid gland, we have a bunch of cells called C cells. You can see here's one C cell. Now, the C cell will actually produce the hormone calcitonin, which is important in calcium regulation in the body. Repeating what we just said, organization of the thyroid gland, it's organized into follicles and C cells between the follicles. Each follicle contains follicular cells that produce thyroid hormones and colloid in the middle of the follicle that consist of glycoprotein molecule called the thyroglobulin. And then we have the C cells that secrete calcitonin. Synthesis and secretion of thyroid hormones. Before we start talking about the synthesis, let's talk about the main ingredients that we need to synthesize the hormones. We need two main ingredients. One is actually the iodine, and the second is the tyrosine. Now, iodine has to be taken up by the diet, since the body cells cannot produce iodine, while on the other hand, tyrosine does not have to be taken up by the diet because cells in our body can produce the protein tyrosine. Now that we talked about the ingredients, let's talk about what will we synthesize using those ingredients. We will synthesize the hormones T3 or T4, or in other words, triiodothyronine, or tetraiodothyronine, also called thyroxine. Triiodothyronine actually indicates that 3 iodine molecules are bound to a tyrosine molecule, and that's why it's called T3, while tetraiodothyronine, or T4, are actually 4 iodine molecules bound to a tyrosine molecule. Now let's understand actually how iodine binds to tyrosine. To explain that, I will explain it the same way I understood it. So let's imagine a roller coaster. I'm terrible at drawing, so ignore this. And then on the roller coaster, you have this vehicle, the big thing with chairs on it. This is a chair. Okay, so let's zoom in on this big vehicle. This is the big vehicle. It's actually called thyroglobulin. Remember we said within the colloid we have a glycoprotein called thyroglobulin in which all the reactions happen there. Now let's draw our chairs. Each line is a tyrosine molecule, and each tyrosine molecule are actually 4 chairs. So 2 in the front and 2 in the back, meaning each tyrosine molecule has a capacity for 4 people, or in this case 4 iodine molecules. In the next slide, I will show you how iodine sits on the tyrosine molecule or how iodine sits on its chair. Now, what can we see here? This is a whole thyroid follicle. Within the follicle, we have small follicular cells, as you can see here, and this is one big follicular cell. This is called the basal membrane, and this is called the apical membrane. To understand how we make thyroid hormones, we need to understand where our key ingredients come from. So remember we talked about the thyroglobulin and how all the reaction happens on the thyroglobulin. And so where does thyroglobulin actually come from? So thyroglobulin is actually made within the ER Golgi complex of the cell. And in the process of production of thyroglobulin, the tyrosine molecules made by the cell are actually incorporated within that thyroglobulin. So thyroglobulin, as you can see, is secreted as a vesicle inside the colloid, as you can see here. Now that we talked about the tyrosine, let's go talk about the iodine. Now, iodine, as we mentioned previously, needs to be taken up by the diet. So you take it up by the diet, and in the GI tract, the iodine is actually transformed into the reduced form, which is I negative. The iodide then moves into the bloodstream. In the bloodstream, only 1/5 of the iodide is actually absorbed by the follicular cell, and the other part of the iodine, the other portion, is actually excreted by the body, mainly by the kidneys. So the majority of iodide within the body are actually situated within the thyroid gland. So you will move iodide from the low concentration within the bloodstream into a high concentration in the follicular cell. So you will move it actually against its concentration gradient. And in order for that to happen, it will move using the iodide sodium symporter, which is a secondary active transporter. This transporter will use the energy coming from the potassium-sodium pump on the same surface of the membrane. This pump will pump sodium outside the cell and potassium inside the cell. When sodium is moved outside the cell, less sodium is present within the cell, and that's why sodium can come in using the other transporter. So sodium will come in with a concentration gradient, while here, as you can see, iodide is moved against concentration gradient. And the process of trapping iodide within the cell is called iodide trapping. And once iodide is trapped, it moves to the apical membrane to reach an enzyme called thyroperoxidase. Now, thyroperoxidase will actually change the iodide from the inactive form or the reduced form into the oxidized form, which is I2, or the active form. It's also called iodine. Once iodine is activated, it moves with the transporter into the colloid, as you can see here. When it goes into the colloid, it will actually bind to the tyrosine molecules on the thyroglobulin. This process is called iodination of tyrosine or organification of thyroglobulin. So let's draw the tyrosine. This is 1 chair, 2 chairs, 3 chairs, and 4 chairs. Now there are 4 options for the tyrosine molecule. The first option is only one iodine binding to the tyrosine molecule, and this is what we call the monoiodothyronine. And I actually call him Lonely Boy, coming alone on the roller coaster. And the second option is a couple in love comes on the roller coaster and sits next to each other. And this is what we call diiodo, so 2 iodines bind to the tyrosine molecule, so diiodothyronine. The third option for the tyrosine molecule is when the couple going on a date find a lonely boy, they tell him, okay, they feel sorry for him, you can come along. So the couple, which is the diiodothyronine, feels sorry for the lonely boy and they bring him along. Plus monoiodothyronine. This is actually called T3. So eventually, if those two join each other, they will give you T3, which is a thyroid hormone. Okay? And the fourth option is actually a couple in love find another couple in love and they go on a double date. This will give you T4 or the other hormone thyroxine. So let's explain what I just said, but on the picture. So if one iodine binds to tyrosine, you'll get monoiodothyronine. And if lonely boy finds the love of his life, he will make a couple or diiodothyronine. Diiodothyronine has 2 options. It can either the couple can either feel sorry for a lonely boy and take them with them on the date, so they take monoiodothyronine. So monoiodothyronine with the couple will give you T3, while if the couple go on a double date with another couple, they will give you T4. So as you can see, the thyroglobulin molecule, maybe it's more obvious in this picture, will have 4 options. It will have some lonely boys staying alone without anyone, and some couple that like the loneliness and stay alone without any interference, and some couple going with a lonely boy, and some couple going on a double date. So those four options are actually present within the thyroglobulin molecule. Okay, now the thyroglobulin molecule is within the colloid. Now we need the thyroid hormones to go outside of the cell, right? So what does the follicular cell actually do, or the thyroid cell? It will start eating up the colloid. As you can see here, it will make a small vesicle, a penocytotic vesicle, and then this vesicle, so it will start eating up the colloid into a vesicle. This vesicle will fuse with lysosomes. The lysosomes contain some proteases. Those proteases will start cutting off the tyrosine of the thyroglobulin. So they want to release the hormones. Then, as you can see here, T3 and T4 are actually released. On the other hand, mono and diiodothyronine are actually not hormones, so we don't want to release them into the circulation. So we want to take the iodine within them and recycle the iodine. We don't want to get rid of that iodine. So the process of taking iodine from within those molecules is called deiodination. So it's done by the enzyme deiodinase. So then iodinase. An important point to mention here is that 93% of the hormones secreted here are in the form of T4, while the rest is in the form of T3. Another important information to mention is that medications inhibiting thyroid hormone synthesis and secretion, or antithyroid medications, work on this enzyme, which is thyroid peroxidase. Let's take a brief comparison between T3 and T4. Do you recall that T3 is actually the couple plus lonely boy? So, lonely boy plus the couple will have a lot of action. They will fight together. Now, the lonely boy will start interfering with the relationship of the couple, so they will fight together, so there's more action, more activity. So that's why T3 is more active, while T4 is actually two couple going on a double date, so no much fighting, they're less active or weaker. Okay, as a general rule, T3 and T4 are actually lipid soluble, so when they go into the plasma, they need carrier proteins. So they need to be bound to proteins. Okay, so as we mentioned, T3, they are a couple with a lonely boy. They fight a lot, so they are less bound to each other. They might even break up because of that lonely boy. So they are less bound to plasma protein. While T4 are more bound to plasma protein. They're not fighting, they stay as a couple. Okay? The other thing is, as a general rule in our body, anything that is bound to proteins are eliminated less. So the more you're bound to proteins, the harder it gets for the body to eliminate that hormone. And that's why, because T4 are more bound to plasma protein, they are not readily eliminated. That's why they have a longer half-life of about 6 days, and other references from 5 to 7. Okay? While T3, because it's less bound, it has a shorter half-life of 1 day. And the last point is that T4 constitutes around 90% of thyroid hormone secretory products, and as I mentioned previously, about 93. It differs from reference to another. And T4 is produced in less amounts by the thyroid gland. However, the majority of T4 is actually converted into T3 peripherally. So the more the organ needs T3, it will convert more T4 into T3. Remember, we want more T3 because T3 is more active. Now, thyroid hormones, key points. Thyroid hormones affect all cells in the body, and that's why the thyroid hormones are actually produced constantly rather than in a pulsatile manner like other hormones. Okay, thyroid hormones are highly lipophilic. We mentioned that. The majority of circulating T3 and T4 are transported by thyroxine binding globulin. So we mentioned they're bound to plasma proteins, and the majority of them are bound to this protein. Only the free portion of total thyroid hormones can exert an effect on cells, meaning that the portion that is bound to plasma proteins cannot have an effect. Only the portion of hormones that are not bound to plasma proteins can have an effect. Now, thyroid hormones has a slow onset and long duration of action. What does that mean? If any disturbances happen in thyroid hormones, you don't see an effect, at least not until several days have passed by. So why is it that they have a slow onset of action? Now, thyroid hormones actually work on receptors within the nucleus, so they have to go into the nucleus and exert their effects. Their effects constitute of gene modulation, and then you have transcription of more proteins, more enzymes. And that's why that takes time to happen. And why the long duration of action? Remember, we previously mentioned they're lipophilic, so they can pass the plasma membranes of cells really easily. When they go within the plasma of the cell, because they're lipophilic, they get bound to plasma proteins. And the release of those hormones from plasma proteins actually happen gradually. So as soon as they're released, they can enter into the nucleus and do their effect. Okay, so they're not released that easily, so they get released gradually. So the released portion will exert an effect, and that's why when the hormones go down, you don't see the effects until a while, because you still have some hormones stored within the cells and released gradually over that period. Functions of thyroid hormones. So one, stimulation of carbohydrate metabolism. They first increase the absorption of glucose from the GI system. If you have more glucose within your GI system, you will have more glucose in your blood. More glucose in your blood will stimulate the uptake of glucose by your cells. When you have more glucose in your cells, you will start breaking that glucose by glycolysis to produce energy. And this is the main goal of thyroid hormones. They increase the metabolism, so they want more energy. So imagine you don't have that much of glucose, there will be increased gluconeogenesis by the liver to produce more glucose. So more glucose can be uptaken by the cells and more glycolysis can take place. Okay? Now, stimulation of fat metabolism. So the thyroid hormones will actually increase the lipid mobilization from fat tissues. So they will start dissolving the fat tissues. If you dissolve your fat, you have less fat stores in the body. Breaking fat or mobilizing fat will increase the fatty acids within the blood. This is very important. If you have more fatty acids within the blood, the cells will take more fatty acids. And those fatty acids can be used to produce energy by a process called oxidation. Now, what is the effect of thyroid hormones on plasma and liver fats? Now, they decrease the concentration of cholesterol, phospholipids, and triglycerides in the plasma. So thyroid hormones increase the basal metabolic rate. Now, what is the basal metabolic rate? It's the amount of energy needed to keep your heart beating, your lungs breathing, your brain functional. Even if you're not doing anything and you're resting, you're sitting on the couch, you're still consuming energy. And this is what we call the basal metabolic rate. Now, the thyroid hormones are actually going to increase the basal metabolic rate. And how are they going to do this? They actually control your consumption of oxygen. So they increase the consumption of oxygen by the cells. So in other words, they increase the oxidation reactions. They increase the reactions that will consume energy. Increasing oxygen consumption will actually increase the depth and rate of respiration. Increasing the metabolism means increasing the energy and heat production, and that's why thyroid hormones are called caloriogenic or heat-producing hormones. Now, what is the effect of thyroid hormones on the cardiovascular system? They can either affect the blood vessels or the heart itself. On the blood vessels, they cause vasodilation by two mechanisms, one of which by increasing the metabolism. When they increase the metabolism, they increase the amount of end products or metabolic products. Those products will cause vasodilation, which will increase the blood flow to that organ that has a lot of metabolism. The other mechanism is actually peripheral vasodilation. The peripheral vasodilation means vasodilation in the skin. And why does that happen? When you produce energy, you produce heat. Heat is something you need to get rid of, so you vasodilate to allow more blood to go into the skin. More blood going to the skin will allow the exchange of temperature and will allow the temperature to go down. Peripheral vasodilation to get rid of heat will cause the peripheral resistance to go down. Decreasing the peripheral resistance will allow the diastolic blood pressure to go down also as well. And now the effects of the thyroid hormones on the heart is by increasing the force and rate of contraction. And this will cause the cardiac output to actually go higher. This is caused by the sympathomimetic effect of thyroid hormones. And what is this effect? Thyroid hormones actually increase the sensitivity of receptors to circulating catecholamines. And they increase the expression of receptors such as beta-1 on the heart. Thyroid hormones also increase the gastrointestinal motility. They also affect the growth. In growth, they affect the bones and muscles. For bones, they actually normally regulate the function of the osteoclast versus the osteoblast. And any abnormalities in the hormone hormones will lead to abnormalities in the bones. Now, on muscles, you can read the slides and we will go through them with the pathology in the next videos. Now, the effect of thyroid hormones on the nervous system. In an infant and a fetus, they're actually important in the development of the normal brain and the growth of the brain. So any hypothyroid child can be mentally retarded and the brain will be smaller in size. Now, as an adult, they don't know the exact mechanism, but the thyroid hormones actually do affect the nervous system, and that is observed in people who have hyper or hypothyroidism. The effect of thyroid hormone on sexual function can be observed in hypothyroid patients or hyperthyroid patients, and I did put a comparison between men and women. What do they actually have? You can read the slide. Okay, thyroid hormone regulation by the hypothalamus pituitary thyroid axis. Starting by the hypothalamus, it produces TRH, or thyrotropin releasing hormone, which will act on the anterior pituitary, stimulate it into producing thyroid stimulating hormone, or TSH. TSH works on the thyroid gland, stimulates it into producing the thyroid hormones. An important point to mention here is that TSH is the most single important hormone in the thyroid hormone production. It stimulates each single step of thyroid hormone production. Another point to mention here is that what affects the hypothalamus? Stress negatively affects the hypothalamus, meaning less hormones are produced, while cold in infants positively affects the hypothalamus or stimulates the hypothalamus, meaning more hormones are produced, more heat is produced for the child. For any comments, suggestions, or questions, you can contact this email. Thank you and have a nice day.